In this kind of example here, where we have not just x squared, but perhaps a power of x that's bigger than 2, so we have an x cubed here, this is an example of a polynomial inequality. A polynomial just involves powers of x's. And here we've got something that's bigger than a quadratic of x to the power of 3. But we use a technique that's very close to what we used for quadratic equations, the quadratic inequalities, I should say. We put everything over to the left. So if you think about that, we have to shift all these two terms over to the left-hand side. If we do that, what we should get is this, x cubed minus 3x squared minus 4x is bigger than 0. And then we try to factorize that. Now notice that x is a factor of this, this, and this. So we could certainly take x out as a factor. And when we do it, we get this expression here. We've got to try and then factorize this x squared minus 3x minus 4 part inside the brackets here. Think about what multiplies to give negative 3 and multiplies to give negative 4 and adds to give negative 3. The two numbers that we'd want would be negative 4 and positive 1. So if we factorize that, what we should get is this. We have x minus 4 times x plus 1, which corresponds to what's inside the brackets here. And we've also got this x outside the brackets. And all of that has got to be bigger than 0. And we set up a kind of we call it a sign diagram with all the possible solutions of, if this were equal to 0, what would the solutions be? It would be x equals 0, x equals 4, and x equals negative 1. So those are the solutions that we're going to have right in here. The roots are going to be positive 4, negative 1, and 0. And if you put those in order of size, what we'll get is negative 1, 0, and 4. And then we've got to figure out what happens over here, what happens over here, in here, and over here. By you could just look at what happens to x, what happens to x minus 4, and what happens to x plus 1 over here, for example. If you choose a value of x less than negative 1, for example, negative 2, that means that x is negative, that x minus 4 is negative, and that x plus 1 is negative. Negative 2 plus 1 is negative, negative 2 minus 4 is negative, negative 2 is negative. So if you do that, what you should get is a negative times a negative times a negative times a negative. And we can figure out later what that is going to give us. Well, we might as well figure that out now. The negative times a negative times a negative. Negative times a negative gives a positive. Times a negative then gives a negative. It's a little bit easier when x is equal to negative 1. We don't need to really worry too much about that. When x is equal to negative 1, that means that this part here is going to be 0. So without worrying too much, we're going to say that the whole thing is going to be 0 at that value when x is equal to negative 1. Between negative 1 and 0, well, between negative 1 and 0, for example, if we choose negative a half, we're going to have this being negative, we're going to have this being negative, but we're going to have this being positive. So it's a negative, and a positive. And you can see that right in here, it's going to be a negative times a negative times a positive. Altogether, that's going to give us a positive. When x is equal to 0, the whole thing again has to be 0. between 0 and 4, well, you can choose a value like 2. If you choose a value like 2, we're going to have x being 2, that's positive. 2 minus 4, that's negative. 2 plus 3, that's positive. So it's positive times negative times positive. And if we do that, that's going to be positive times negative is a negative, times a positive is going to be a negative. For 4, it's again just going to be 0, and anything above 4 is going to be positive, positive, positive. And so if we do positive times positive times positive, we're going to end up with something that's positive. Now think about what the question was asking. It was asking, when effectively is this positive? It's positive here and here. In other words, it's when x is between -1 and 0, that's right in here, or it's when x is bigger than 4, right over here. Now a similar thing happens for example 7. It's almost exactly the same kind of technique. We're interested in when this thing is less than or equal to 0. The factors are already there. The roots are going to be when x is equal to 1 and when x is equal to -2, because those are the things that make this whole thing equal to 0. Okay, so if we put down what the roots are in this table, it's -2 and 1. We then just investigate what happens to the factors. So this is going to be quite a slow process, but we'll try and do it as quickly as possible. The x minus 1 squared for any value of x that's less than -2 is going to be positive. X plus 2 is going to be positive for any value of x, or sorry, think about x plus 2. If you have a value of x that's less than -2, for example -3, -3 plus 2 is going to be negative. So we'll have a positive and a negative, and if we multiply those two things together, what we'll get is being a negative. And to save time, I'm just going to do the rest of those very quickly now. So notice that we're asked, when is this whole expression less than or equal to 0? So we're looking at where it's negative or equal to 0. So it's here or right here. So if you want to write the answers for that, it's going to be this whole thing here, the x minus 1 squared times x plus 2 is less than or equal to 0 when x is less than or equal to -2. If you want to do that a little bit more quickly, just put the roots -2 and 1 in here, and then do the calculation for whether this would be positive or negative in one step. If you do that, you'll get positive times a negative, giving us a negative. It's going to be 0 in here, of course. Between -2 and 1, well, again, you're going to have the x minus 1 squared thing is always going to be positive, and then if you have a value of x that's more than -2, the x plus 2 is going to be positive also. So we're going to have a positive times a positive, giving us a positive. Again, the x equals 1 is going to give us 0, and if we choose any value of x that's bigger than 1, we're going to have everything being positive, giving us a positive. So again, we can see that the only times that this whole expression here is going to be negative is when x is less than or equal to -2.